An experiment involves two substances, substance 1 and substance 2, whose masses are changing. The mass m1 grams of substance 1 at time t hours is given by m1 equals 400 e to the minus 0.014 t. The mass m2 grams of substance 2 is increasing exponentially, and the mass at certain times is shown in the following table. A critical stage in the experiment is reached at time t hours, when the masses of the two substances are equal. Find the rate at which the mass of substance 1 is decreasing when t is 10, giving your answer in grams per hour corrected to significant figures. Show that t, capital T, is the root of an equation of the form e to the kt equals c, where the values of the constants k and c are to be stated. Hence find the value of capital T correct to 3 significant figures. So let's have a look at this, and I've tried to summarize the question as best as I can here, and we're told that m2 is given by this table here is growing exponentially. So m2 is growing exponentially, so you would think that m2 would equal a e to the bt, where a and b are constants and b is positive, is what you would think, wouldn't you? Because these are increasing. So we could put the values in here into this to work out a and b, couldn't we, for m2? So I'd like to do that at the outset before I even look at the questions. So here's my table. So m equals m2, that is a e to the bt. T equals 0, m2 equals 75 gives, so 75 will equal then, put t as 0 and e to 0 is 1, is a. So a is equal to 75. Now let's have a look at the other value here. 10 is 120, so we could put that in. T equals 10, m2 equals 120 gives. So put that in, then m2 is 120 is equal to a, which we know to be 75, e to the b times t, which is 10. So that tells us then that e to the 10b then is equal to 120 over 75. That's 24 fives, and this is 15. 24 over 15. 24 over 15. So I moved the 75 underneath and tried to simplify the fraction as best I could. But this is now divided by 3, that's 8 fifths. 15 is 8 15, so I could have divided by 15 straight away. So here then we now know that 10b, take logs and move the e to the base number, 10b is equal to ln of 8 fifths, and that now tells us that b is equal to 1/10 ln of 8 over 5. So there's b. So we've got a and b for m2 now, which was helpful. So now let's go back to our question. We know at time t the two masses are equal, so I'm just going to use that piece of information as well. So at time t, at t equals t, m1 equals m2, and that gives, so I'm just working my way through all the information from the question really before I even think about answering it. So m1 equals m2, m1 is 400 e to the minus 0.014, so 400 e to the minus 0.014 capital T is equal to a e to the bt, wasn't it, a, which was 75, e to the b, which is 1/10. So I can move that up to a power, and it's going to be log n of 1.6 to the power 0.1, because that's 1/10. Okay, that's what we've got there. 75 e to the b times t, e to the log n of bt. So this log number's here, isn't it? Okay, so that would equal then 75. So I can split this up as power, so it's e to the log n of 1.6 to the 0.1 all to the power t, which is equal to 75. E to the log now cancels. It's 1.6 times 0.1 to the power t times power u times, so it's 0.1 t. So that's what we've got then. So this is capital T, of course, so let's put that in. We should have written that. We should have wrote that at the outset. Capital T, and capital T. So 400 then, e to the minus 0.014 capital T is equal to this, is what we've got. Right, now let's go back to the problem then. Find the rate at which m1 is decreasing when t is 10. So m1 is decreasing when t equals 10. So m1 was equal to this here in general, wasn't it, at time t. So the rate at which that's decreasing, so dm1 dt is equal to, differentiate, this comes down, 400, e to the something differentiates to e to the something, times t multiplied by the something differentiate minus 0.014. That differentiated, this is a t, sorry, so that just goes to that. So what does that equal then? Well, it's negative, and then let's just do 400 times 0.14. So it's 400 times 0.014, 28 over 5. So it's minus 28 over 5 e to the minus 0.014 t. So when t was what? T was 10? Okay. So that's equal to, at t equals 10 then, dm dt is equal to minus 28 over 5 e to the minus 0. Times this by 10 is just 0.14. So we've got 28 over 5 times the exponential to the minus 0.14. And let's, don't forget that negative is tagged. Minus 4.868. Minus 4.868. Now what did it want the answer to? Let's have a look. In t is 10 in grams per hour. Doesn't say. And that's equal to minus 4.87 to 2 decimal places. And that's grams per hour. Okay, so that's the rate of decrease. So that's part 1. Show that t is the root of an equation of this form, e to the kt equals c. So again, we've done partially that problem. Right, so we've said that that satisfied the equation here, didn't we? Okay, so e to the kt equals c. So I need it in e to the kt equals c. Okay, so it's asking me to write it in exponential form. So we need to write it like so, won't we? So what have we got then? We'll have this then. So part 3, or part 2, isn't it? What are we going to do then? This is e to the something t. So 400 e to the minus 0.014 t is equal to 75 e to the, I'm just going to put b instead here, t, so I know what b is. Okay, good. So that then tells us if we move this over there, times by this, both sides, 475 e to the b plus 0.014 times t. So that tells us then that 400 over 75, which is 16 over 3, isn't it, is equal to e to the b plus 0.14 times t. So that's the form we wanted, didn't we? Because that's what they said above. Show that this is equal to that. E to the kt equals c, and find, so c and k. So that tells us then that c is equal to 16 over 3, and k is equal to b plus 0.14. 0.014. Which equals b is none other than, let's just go and get it again, sorry, log, natural logarithm of 1.6 times 0.1. 0.1 ln of 1.6. 1.6 plus 0.014. There's b. Okay, so that's good. And now it says solve for t, so now we just need to solve for t. So if we've got that, then it will tell us, I'm just going to do it here. So take logs, so this times that comes down to ground level, so I'm just going to write t equals, and when you take logs you get natural logarithm of 16 over 3, and that will be, and then this, when this has come down to ground level, this constant here multiplies here, we can move that underneath to be b plus 0.014. So t equals then, so we can tap this in the calculator. So here's the b plus 0.014, so it's log of 16 over 3, so let's tap that in. So it's awkward numbers, but it should be doable. So it's the natural logarithm of 16 divided by 3. So that number divided by, bracket, b plus 0.014, which is 0.1, times the log of 1.6, and then 1.6, plus, close the bracket, plus 0.014. Close brackets, equals 27.442. 27.442. And that's capital T. Does it say what we need to find it to? 3 significant figures. So it's 27.4 then. And that would be hours, wouldn't it? To 3 significant figures. Okay, I think it was the time was measured in hours, but the answer is 27.4 of these units.